So I only decided to do this lab because it was so terrible, and I thought, well, it's probably a really good example to give to students about how not to do a lab. So the first thing that you never do is you never do discontinuous data, which is comparing apples and oranges. You always do continuous data, so you never do a bar graph, which is what we're going to do. So you're trying to compare newspaper to wool. But those things are different colors, which have a huge influence on how much heat they absorb. They have different reflective abilities, so there's radiation issues. So it's not just how well it conducts. They're obviously different thicknesses, and you're going to see, as you can see in the lab as we're setting it up, there's different coverage as well. So you haven't controlled any of variables, so you can't really get anything valuable out of it. The whole entire design is quite bad as well. So we're just putting 100 mils of hot water into the cans. And because I only gave it one lesson, we didn't finish it. We only got to 10 minutes and we haven't done the analysis. So I'm asking you to watch this video instead. And so that's the data that we got from the students. And so you're meant to put it into a bar graph. So I just copied and pasted across. And so you're just going to insert a bar graph, and there you go. Now the big problem, I'm not going to work on this because it's not worth it. That all-in-one is, students want to just play around with it, so I let one student just build it all up and do what he wanted to. And yeah, the problem is with heating, it's an exponential curve, so it drops really rapidly, really quite quick, and then curves off. And so you really do need to take many, many trials to see what the standard deviation is and how big the error bars here on these curves are. So the fact that you really just need to pick on one thing and maybe just see what the thicknesses are, and then you can understand a relationship between thickness and that material. Whereas if you're comparing two materials, you don't really know what it is, what property. There's so many properties different properties between the two. You don't really know what the factor is that's causing the better insulation. And so you can see that these kind of curves, so you can't really tell anything actually, and you don't know whether they overlap as well, whether there's error bars here will completely overlap with each other, which looks likely. So that's kind of quite terrible. And so the questions are, draw a bar graph. I did. Which one appears to be the most effective? You can't really tell. Maybe the all-in one, but it started at it started at a lower temperature and it kind of is higher up, but you're not sure whether there's a huge error bar there, so that the entire lot overlaps, so there's not enough trials to really tell. So which one of the which one or more of the three methods of heat transfer does the most effective? Well, that's conduction. It's not really helping with convection, and radiation will be a tiny bit. So I can't really suggest which one's a good one for your mug, for your chocolate holder. I was one left without a covering as a control. Sorry, that's that one. I thought it was covering over the top to stop convection. And so I've already mentioned this whole thing's unreliable. So hopefully that is quite useful to you to see what a bad experiment looks like and how not to do one. So really just pick one material and maybe change the thicknesses. So 1 layer, 2 layers, 3 layers, 4 layers, 5 layers. And you can see what the most effective layer is for or when it becomes non-effective to get extra layers, when adding more layers has no more extra effect. So what is the maximum or ideal thickness you need? Something useful that's on a continuous scale on a scatter graph.